This is the second note of Unit 3 on quadratic relations. We are going to be talking about vertex to standard form. So as just a quick review from last year and from grade 9, y equals mx plus b is that equation that we used for a straight line, right? We focus on quadratic relations in grade 11, but back in grade 10, you really focused on this slope y-intercept form. So this was the equation of a straight line in what we call slope y-intercept form. Okay, slope y-in form. Okay, this other equation should also be familiar to you. So it says ax plus by plus c equals 0. So this is also an equation of a straight line. So I'm just going to put little quotations. That's just to say, yep, this is also the equation of a straight line, but this is in standard form. Okay, so when you were looking with or looking at those linear relations, those straight lines, we saw them in two different forms. So therefore, when we're looking at these quadratic relations, this is just kind of to show you that we can write the same thing in different ways. So what we focused on in the last unit in our quadratics part 1 was this vertex form. So this equation is vertex form of a quadratic relation. Quadratic relation. Okay, this other formula, y equals ax squared plus bx plus c, is the standard form of the same quadratic relation. Whoops. Standard form. And again, these quotations are just saying of a quadratic relation. Okay, so let's try to discover something here. Okay, so it says sketch the following equation. So from last unit, we dealt with this vertex form, right? So we know just by given this equation in vertex form, we're able to actually draw this graph, right? So the first thing we needed to figure out was what is the vertex, okay? The vertex here, remember that's HK. So vertex was HK, so we just have to pull those out of our equation. Remember the H is always the opposite. So instead of -2, it would be +2, and my K value is 1. So I can go ahead and plot that point. Okay, the second thing we needed to do is figure out our step pattern, right? So in this case, we don't see an A, which means it equals 1. So our step pattern is going to be exactly the same as our base graph. So 1, 3, 5, etc. Because there's no negative out front, we know that we're opening up, so we can simply use that step pattern to graph. So I'm going to go over 1, up 1 on both sides, and then from there, over 1, up 3, 1, 2, 3, put a point, 1, 2, 3, put a point. And lastly, over 1, up 5, 1, 2, 3, 4, and that's basically off our grid there. Okay, and then of course I would connect the lines. And you know I struggle on my tablet with this, so bear with me. Not perfect, but you get the idea. Okay, so we are going to do the exact same thing for the second one. It says use a table of values to sketch y equals x squared minus 4x plus 5. So at this point, we really don't know how to graph that unless we use our table of values, right? Which is how we actually started out graphing in our second unit at the very start, right? We just used a table of values to figure out the coordinates. So we're going to do the same thing here. So remember, it's giving you the x. That means you're just using substitution, plugging that x in to solve for y. So we have negative 1 squared minus 4 times negative 1 plus 5. Negative 1 squared is 1. So you have 1 plus 4, right? Because 4 times negative 1 is plus 4 plus 5. So 1 plus 4 is 5. 5 plus 5 is 10. So our coordinate is negative 1, 10. Okay, and we're going to just keep doing the same thing. I'm not going to verbalize it every single time. Anything, 0 times itself is just going to be 0. 0 times anything is just going to be 0 plus 5. So that's going to equal 5. So we have the 0.05 on there as well. 1 squared is 1. 4 times 1 is 4 plus 5. So we have 6 minus 4, so that would be 2. We have the 0.12. 2 squared is 4. 4 times 2 is 8, so minus 8 plus 5 will give us 1. So we have the 0.21. And of course, you could just check this on your calculator. I know I'm running through it pretty quick. 3 squared is 9, minus 12, right? 4 times 3 plus 5 gives me 2. So I have the 0.32. And lastly, 4 squared is 16, minus 4 times 4, which will also be 16, plus 5, which leaves me, whoops, that's a 5, not a 3, with the 0.45. Okay, once I have those points, obviously all I have to do is graph them. So I have a point at negative 1, 10, so all the way up here, 0, 5, 1, 2, 2, 1, 3, 2, whoops, 3, 2, and 4, 5. So if I go ahead and connect those, I'm just going to leave that top one out. Okay, so what do we notice about these two graphs? And on mine, it might not be as clear just because, again, graphing on here isn't the easiest thing. But what you should notice is that the graphs are the same, okay? The vertex on the left-hand graph is at 2, 1. The vertex on the right-hand graph is at 2, 1. Right? The y-intercept for both of them is at 0, 5. Okay? So they are the exact same graphs. So what we notice is the graphs are the same. What this means is that the equations are the same, but they're written differently. They're written differently. Okay, so just like with those straight lines, those linear relations, where we had the slope y-intercept form and standard form, we also have multiple ways of writing the same equation for quadratic relations. So that's part 1 of the note. Let me just pull up part 2. Okay. Awesome. So part 2 here says recall expanding. So let's just quickly review how we expanded. Okay, so this is from that first note. So for this first one, I have a monomial multiplied by a binomial. So all I have to do is my distributive property, right? So again, those arrows just indicate that you're multiplying the terms together. So we have negative 3 times 2x, which would give me negative 6x, and negative 3 times positive 3 gives me negative 9. Okay, this second one is one of those special cases that we talked about in the second half of the first note. But again, if you can't remember that, no problem, just simply write both of those out and use FOIL. Okay, I do remember, so I'm going to just use that. I know that my first term is my first term above squared. I know that my second term is 2 times my first term, so 2 times 1x, so 2x times my second term, which is negative 2, is negative 4x, and my last term is that second term squared. So negative 2 squared is 4. Okay, and then the last one here, so this one we have to kind of combine number 1 and 2, right? We'll have to use that distributive property, but we'll also have to use FOIL or remember that special case of that binomial squared. So again, I am going to just simply remember. So just like I did for part 2 here. So I know the first term is the first term squared. The second is 2 times that first term times the second term. So 2 times 1x is 2x, times 3 is 6x. And my last term is this last term here squared, so plus 9. Okay, once I've done that, I am now going to use my distributive property. Okay, that means I'm multiplying that negative 2 by everything inside my brackets. So I have negative 2x squared minus 12x minus 18. Okay, so the reason we are reviewing this is because we can use this to help us write each of the quadratic relations in standard form. Okay, so in order to write something in standard form, we need to use expand and simplify. So I'm going to just write that here as a note. So by expanding and simplifying. All right, so let's do that. So again, you can remember the rule or you can write the whole thing out. So for these ones, I'll write the whole thing out. So if we don't remember the special formula for a binomial squared, what we're going to do is we're going to write out that binomial twice and use FOIL. Okay, remember FOIL is just the order in which you're multiplying everything together. So F stands for first, so x times x is x squared. O stands for outside, so x times positive 6 is positive 6x. I is inside, so 6 times x is also 6x. And L stands for last, which is 6 times 6, which gives me 36. Okay, so I've expanded using FOIL. Now I need to simplify, which just means collect my like terms. So I can see I have 2 x terms there, so I need to add or subtract their coefficients. In this case, they're both positive, which means I need to add. So 6 plus 6 is 12x plus 36. Okay, and notice if you flipped your page over and looked at that standard form formula, this is written in that exact form. So that form was y equals ax squared plus bx plus c. Okay, and we can see that that looks very similar, so it's in the correct form. Okay, we're going to do the exact same thing for these other 2 examples. I should probably write a bit smaller if I'm going to fit it. I'll change colors just so you can tell that I'm moving to the different question here. Or I'll just draw a line actually. There we go. Okay, so same thing here as what we had to do with 3 above. We're going to have to use FOIL and distributive property here. Okay, so again, the first thing I'm going to do is I am going to use FOIL. This time I'm not going to write it out. I'm just going to simply use that formula I learned, which tells me that the first term is just squared. The second term is 2 times the first term times the second term, so 2x times negative 7, which is negative 14x. And lastly, negative 7 squared is 49. Okay, once I've done that, now I am distributing that negative 2 to everything inside my bracket. And remember, the word distribute just means multiply. So negative 2 times x squared is negative 2x squared. Negative 14x times negative 2 is positive 28x, and negative 2 times 49 is negative 98. So again, you'll notice that that's in proper form, right? It's very similar to what I have over here written in green. Okay, last one here, so we can see this one. These are all in they're in vertex form, right? Just some of them don't have all of those transformations applied. So I will switch my color again just to make it clear. Oops. So again, I need to properly expand and simplify this. It's going to involve both the FOIL and the simple distribution. I guess I have to zoom in so I can see. All right. So I'm going to leave that 3 out front. I'm going to write out my brackets this time, just so you're clear. Minus 8. All right, so I need to FOIL again. Oops, that's a 3, which just means I'm multiplying all of these terms together. X times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is 25. And don't forget about your minus 8. Okay, that's not involved in the distribution because it's not in the brackets. My next step will be to simplify inside my brackets, so that just means collect my like terms. Negative 5 minus 5 is negative 10. And that negative 8 is coming along for the ride. Okay, now I need to distribute that 3 into my brackets. Okay, so each term in my brackets needs to be multiplied. 3 times 3x is 3x squared. 3 times negative 10 is negative 30x. And 3 times positive 25 is positive 75. And then again, just carrying that negative 8. We're not distributing to that negative 8 because it's outside of the brackets, right? We're only distributing inside of those brackets. So again, last step is we need to collect those like terms, which we can see these are both numbers without any variables, without any exponents. So we can add or subtract those. So it's going to be 75 minus 8, which gives me 67. Okay, and again, we knew we had to take that extra step because you'll notice this line here does not look the same as this green line over here, right? It has an extra term there, so it's not fully in standard form until we simplify it. All right, so let's just summarize this in a little chart here. So we've been dealing with vertex form a lot, right? So this should be a review, but our vertex form is y equals ax minus h squared plus k, where our vertex is at hk, okay? So, what are we doing here? We are filling in the blanks. So the first blank is determining the vertex of this other relation that we're given, right? So the vertex we know is hk. So again, when we pull that out, the sign changes for the h and it stays the same for the k. Okay, now it's asking us to write this vertex form equation into standard form. We know how to do that. We simply need to expand and simplify. And this time, again, I'm not going to show you all that work. I am just going to do the little trick. So my first term is squared. 2 times x is 2x. 2x times 2 is 4x. And 2 squared is 4. And then we have that minus 5 at the end. Okay, I can now just drop my brackets and collect my like terms. So y is going to equal x squared plus 4x. 4 minus 5 is negative 1. Okay, the y-intercept is the value of c in standard form. So we can see, as soon as we have this in standard form, that my y-intercept is going to occur at 0, negative 1. Okay, the reason for the 0 is that your y-intercept, remember, for it to actually cross that y-axis, your x value has to be 0. So generally, the y-intercept is always going to be 0, c. Okay, and it's asking, is this the same parabola? Yes, it is absolutely the exact same thing as we saw in that first page where we graphed the standard and vertex form of the equation. Okay, almost done. Just a quick couple key concepts here. So a quadratic relation, and this is a lot of filling in the blanks, so I'm going to try to write it as neat as possible. A quadratic relation can be written in vertex form, which is y equals ax minus h squared plus k, or in standard form. Okay, and that formula you'll also need to know is y equals ax squared plus bx plus c. Okay, expand and simplify. The vertex form to write the quadratic relation in standard form. Given the quadratic relation in vertex form, y equals ax minus h squared plus k, the coordinates of our vertex are always going to be hk. If we are given the relation in standard form, on the other hand, the y-intercept is always going to be c. Okay, so that's just a general key concepts from this second lesson of the unit.